Dennis, just quickly, Emily Pollock just joined us, and she'll be your
Hi.
graduate student host. So
Great.
Okay, I think we're going to get started. We have a slow pace of entry today, but we're a couple minutes past. So welcome everybody. We have another super speaker this week. We're super excited to hear from him, and also our host that I will introduce, who will be moderating today. So we have our own Dr. Zach Almquist, known to everybody, who recently gave a talk here. So thank you so much, Dr. Almquist, for arranging this and inviting Dr. Feehan. So I'm gonna go ahead and just let you take over. I will remind everyone first, though, that please go ahead and put your questions in Q&A as you think of them, or just write that you have a question, and I can, at the end, click on you, and you can go ahead and ask the question directly, and that way you can communicate directly with Dr. Feehan. And also, we do have a student meeting afterwards, so we'll put that link in the chat, but please don't use chat, but we'll put the link in there for you so you can go to that meeting after this seminar. So again, thanks so much, Dr. Almquist. I'll let you take over.
Thanks, Maria. I'm super excited, excuse me. I'm super excited to have Dennis here for the CSD seminar. I'll do the world's briefest introduction. Dennis is an assistant professor in demography at the University of California, Berkeley. Before that, he did his PhD at Princeton, also in demography, and he's an extremely accomplished demographer, publishing in places like Demography, Sociological Methodology, and The Lancet. And we're really lucky to have him here, and I'll let him start his presentation.
Great. Thank you so much, Zach, and everyone for hosting me. I'm really excited to share this work with you. Let me see. So I think I just shared my screen. Is that good? I'm going to assume somebody will stop me if you can't see my screen now. So great. So I'm going to be talking today about a project I've been working on for a little while, and this has been parts of this are in a few different papers, and so I definitely want to mention my collaborators on some of those papers: Matt Selganik, Mary Mahey, Alina Moubier, and Wolfgang Ladek. And I thought I'd start by just trying to talk a little bit about the problem that this work is hoping to try to help address, and that is the challenge of estimating adult death rates. So this is a demography seminar, so I think probably we're mostly on board with the idea that adult death rates are important, but just to kind of highlight what we need adult death rates for, they get used to calculate life expectancy. They're essential to understanding the impact of big health events like the COVID-19 pandemic or the spread of smoking. They're crucial to understanding inequalities in health, population health, and they're useful for making all kinds of policy and economic plans around labor markets, social security systems, that kind of thing. So they're pretty important. And in a country like the US, we have information about adult deaths from our death registration system, which produces a death certificate for essentially every person who dies. And we can use the information from those death certificates to produce death rates. But a lot of the world doesn't have a system that produces a death certificate for every single person who dies. So this is a map from a recent paper in the Lancet, not by me, that was looking at the extent to which death registration systems are complete. And just by kind of looking at the map, you can see that in a lot of sub-Saharan Africa and big parts of Asia, there aren't systems to register every single person who dies. And so in these settings, we have to come up with some alternative way to estimate death rates. I'm going to talk today about estimating death rates from sample surveys, because one thing that we have gotten pretty good at over the past few decades is sampling and interviewing people, even in settings that are challenging to work in terms of kind of data availability and so forth. So if you think about it for a second, though, it turns out that trying to estimate death rates or measure mortality from a survey is a pretty difficult problem. And I think there's two big reasons why it's difficult. The first is that we're used to conducting surveys where we sample people and ask them to tell us about themselves. So for example, we might sample people in a health survey and ask them whether or not they've received a flu shot in the past year. But that approach won't work for deaths because we can't sample and interview people who have died. So we have to have some other strategy for learning about deaths from a survey. And then the second challenge is that even if we could interview people who had died, death at adult ages is a pretty rare event. Even in settings where death rates are relatively high, it's still a pretty rare event. And so that means that it's challenging to get a big enough sample to estimate death rates with enough precision to be useful. And so I'm going to talk about two different approaches to trying to overcome these challenges today. The first approach is called the sibling survival method. And this goes back quite a ways in demography. The big picture idea here is to ask survey respondents to list their siblings, when they were born, whether or not they've died. And you can kind of see that from that information, from those responses, there'll be information that can be used to calculate death rates at adult ages. And in light of the two challenges that I just described, this is pretty appealing because by asking people about siblings, we can learn about people who we don't directly interview, including people who have died. And we also, in places where SibShips are moderately sized, we learn about more than one person from each respondent, because a respondent will tell us about her siblings. And so we get information about several people from just one interview. So that's good in terms of sampling and efficiency. But there's still some challenges with the sibling survival approach. It turns out that even though we do learn about more people from each interview, in many situations it appears to still struggle a little bit with the sample size, meaning that we don't learn about enough siblings per interview to produce precise death rate estimates unless the survey sample is really pretty big. It's a complicated method, and there's a healthy amount of disagreement about how the data should be analyzed. And then it also is really not designed for some situations like disasters, short time frames, estimates that are geographically targeted, and so on and so forth. So, so there's some ways that the sibling method could potentially be improved. And the big picture idea here is, well, what if we try to go beyond SibShip and ask about other types of social relationships? So people who survey respondents are connected to through relationships other than being siblings. So this is kind of what I worked on in my dissertation, and the idea was to kind of start from the sibling survival method to try and develop a set of formalisms that could be used to understand the sibling survival method, and then to use those formalisms to produce a new method that is based on this idea that that people can be asked to report about other types of relationships other than just siblings. So this new approach, the network survival method, is kind of a mashup of the sibling survival method and an approach called network scale-up, which some of you might have heard of. But the idea is to kind of try to take strengths from different existing methods and produce something that might be able to overcome some of the challenges with sibling survival. So I'm not going to explain in great detail how the network survival method works, but I am going to try to work through a toy example just to start to give us some intuition for what it, how it works. So this toy example shows a population that has 7 people in it, and 2 of these people are dead, and everyone else has been interviewed and asked to report about the people they are connected to who have died. And every time that someone reports that someone has died, that's indicated by a directed arrow. So for example, person number 1 here is reporting that person number 5 has died. So it turns out to be useful. So this picture contains all of the information that we need to derive the estimator that I'll describe in a second, but it turns out to be helpful from an explanatory perspective reformat the picture a little bit in this way. So to move from this picture on the left to the picture on the right, I've just taken all of the nodes in the population and I've made 2 copies of them, one on the left-hand side here and one on the right-hand side. And now every time that someone makes a report about someone else being dead, that report travels from the left-hand side to the right-hand side here. And this way of arranging the nodes is useful because it just makes it really clear that there is an identity here, that these reports are conserved in some sense across this across the 2 sides of this diagram. So what I mean by conserved is that the total number of reports that are made by people who report has got to be equal to the total number of report times that people are reported about. Or mathematically, you could say that the total number of out reports, so that's reports that leave this left-hand side, should be equal to the total number of in reports that arrive on this right-hand side. So then we can kind of take the fact that these 2 totals are equal, and we can decompose this total number of in reports as a total. It's the number of deaths times the average number of times each death is reported. And then we can rearrange that expression to solve for the number of deaths. So what we see is that the number of deaths is equal to the total number of out reports divided by the average number of times each death is reported. And if you want to step back and think about this for a second, it kind of makes sense, because if we just added up the total number of times that people made reports about deaths, we'd get a number that we think should be bigger than the number of deaths, because each death could be reported about more than once. And so dividing by the average number of in reports per death adjusts for that fact. And this quantity, the average number of in reports per death, is I'm going to call this quantity visibility. So it's the number of times the average death gets reported and sort of how visible death is. One other quick kind of comment, which is that this picture is useful for understanding how the estimator is derived. But in reality, we collect data that look a little bit more like this. We don't see exactly who person number 1 reports to be dead. We just know that person number 1 reported somebody to be dead. And that's okay, because if you look at this expression, it only involves totals and averages. It doesn't involve knowing in great detail who reports about them exactly. Okay, so this is the relationship that I just kind of quickly motivated. And to get an estimate for a number of deaths from a survey, we have to figure out how we can estimate this numerator and how we can estimate this denominator. So I'm just going to give a little bit more information about that. First, I'll talk about the numerator. So remember, this numerator is the reported connections to deaths. And so this can come from a question like, how many people do you know who died in the last year, which we can ask in a standard survey. I'm going to put aside for a second what it means to know somebody. Let's presume that we've just decided on that. But if we ask a question like that on a survey, let's imagine a respondent reports that she knows 3 people who died in the past year. We can ask her to provide more information about those 3 people. So in this case, the sex and the age of the 3 people who died. And then using this additional information, we can estimate the total number of reported connections to death by sex and age in the population. Okay, so that's kind of how the numerator works. What about this denominator? Well, this is a little trickier. If you think about it for a second, you'll probably come up with a few different ways to try and estimate the average number of times each death would be reported. The network approach I'm going to talk about today uses a pretty simple strategy, which is to say, we're going to use the network sizes of the survey respondents to estimate or approximate the visibility of the people who died. So just to make that a little more concrete, if the survey tells us that female respondents aged 50 to 59 have an average network size of about 200 people, then we're going to assume that a woman aged 50 to 59 who dies would be reported 200 times in a census. In other words, the visibility of women aged 50 to 59 is 200. So we're using the networks of the people who respond to the survey to approximate something about the networks of the people who died. This approach should work reasonably well if people are reporting accurately, if they're aware of which network members died, and if it's indeed the case that people who die have networks that are similar to people who responded to the survey. The papers kind of think about these assumptions quite a bit, and so if you're interested in understanding what happens to the estimates if they're violated, I'd encourage you to check them out. Okay, great. So that's just some big picture intuition behind how the new estimator works. And now I'd like to just talk a little bit more about how we can think about what sort of relationships we might try to ask people to report deaths in beyond just sibling. And so I'm going to think here about this in terms of how we think the strength of the network relationship will affect the error in the resulting estimate. So what do I mean by the strength? Well, in social networks, there's this notion that some ties are stronger and some ties are weaker. Many of you are probably familiar with that. And I'm going to try to think about what we expect to happen in the error and estimates as we move from asking questions about a relatively strong tie to a relatively weak tie. And a strong tie here is something like the sibling relationship is pretty strong in this context, and a weaker tie is something like acquaintances. So one way that changing the type of relationship that we ask about will affect the error is through sampling error. So it's pretty clear from the literature on networks that we expect stronger tie networks to be relatively small and weaker tie networks to be relatively large. And so from the perspective of sampling error, that means that we learn about more information in some sense from weaker tie responses. And so that means that the sampling error, all else equal, should be lower for weaker tie networks. On the other hand, it's also pretty clear from the literature that we think that people will tend to know more accurately about others they're connected to through strong tie relationships as opposed to weak tie relationships. So what that implies is that we predict that the non-sampling error will probably be higher for weaker tie reports than it will be for stronger tie reports. At the end of the day, what we're interested in is making estimates that are as accurate as possible. And so we care about the sum of the sampling and the non-sampling error. And if these hypothesized relationships are correct, then there may be some kind of sweet spot in the middle where the total error is minimized. And so what that means in practice is that this is a framework for trying to think about how different types of relationships might produce different types of errors in death rate estimates. I think of the sibling method as being kind of way at the extreme strong end of this spectrum. And we're going to kind of try a different type of relationship here that's maybe more towards the weak end of the spectrum, and we're going to see empirically how they seem to compare. So just to kind of recap, in the sibling survival method, respondents report about deaths among their siblings. Because it's a relatively strong tie, we expect that each interview will produce relatively small amount of information, but we think that respondents will be reasonably well informed about their siblings. And the kind of reverse is true for the network method. Respondents will report about deaths among people in their network. We think that there'll be more information per interview, but it's a little less clear how well informed respondents will be about their network members. And so the kind of key empirical questions are, first, this network method is quite new. And so, does it work at all? Does it produce estimates that look reasonable? If it does, which approach should we use? Should we use the sibling method or the network method? Is there something we can say about which one is more accurate? And then finally, is this kind of framework I discussed here, is this a productive way to think about how to try to come up with relationships to ask questions about on surveys? Is there any empirical support for this prediction? Great, so I'm going to start by kind of very quickly recapping the first network survival study to sort of set the stage a little bit, and then I'll talk about some new data that my colleagues and I collected in Brazil. So this is the first network survival study that was conducted. It was on a random sample of Rwandans conducted through a household survey. The design of the survey was intended to mimic a demographic and health survey. So it had a complex sampling design, and all of the estimates that I'm going to talk about today, both in Rwanda and Brazil, kind of use weights to account for the sample design. Embedded in this survey was an experiment that tested questions about two different types of networks to kind of start to get some evidence about whether or not this quantity-quality trade-off appears to be right. And I don't have time to talk about that in detail today, but you might be interested if you find this compelling. And what I'm going to talk about today is comparing the death rate estimates produced from these two networks to the sibling estimates that come from a DHS survey that was conducted at about the same time. So the first thing I'm going to look at is the average number of deaths that got reported from each interview. And so this is something that I'm using to kind of get some purchase on this idea of sampling error, because the uncertainty in an estimate for a death rate is going to be driven mostly by the number of deaths that are reported. And so this framework predicts that the network question should produce lower sampling error because people should produce more deaths per interview than the sibling method. So we found empirically that that was true. For the average number of deaths reported per interview was quite a bit higher for the two networks that we looked at when compared to the sibling method. In fact, the network reports were produced between 4 and 7.5 times more deaths than the sibling method. Let me actually just take a quick aside and explain this 7-year sibling method thing. So I mentioned at the beginning that sample size is a challenge for producing sibling survival estimates. And what that means is that in practice, people often produce estimates for 7-year time periods. They pool 7 years of reports together instead of just looking at the year before the survey. So because that's standard practice in the sibling literature, that's mostly the estimator that I'm going to compare to today. Okay, so then so we found that the network methods did produce reports about more deaths. And then when we calculate death rates and summarize those death rates with this estimated life table probability of death at adult ages, we find these are the two estimates from the two different network methods that we tried. These are the estimates from the DHS sibling method. And then these are 3 estimates produced by different organizations that use a lot of modeling and combining data from all sorts of different countries to try and produce estimates. And so you can see that the estimates produced from the network survey-based methods are certainly not unreasonable. There's a pretty high amount of agreement between the 3 male survey-based estimates and a little bit less agreement from the female estimates, but we don't have a gold standard in Rwanda, so we really can't say which of these is the most accurate. So just to kind of recap, we found from this first Rwanda study that it's feasible to conduct one of these network survival studies, which was far from obvious before we actually collected the data. Kind of consistent with what we'd hoped, we did learn about considerably more deaths from each interview using the network methods. The age-specific death rates that were estimated are roughly similar between the sibling method and the 2 different network tie definitions, but we can't really tell which one is the most accurate because there's no gold standard in Rwanda. So that kind of brings me to this next study, which is from Brazil. I've been working on this for a long time, and I'm finally at the point where we have some results to show, so this is kind of exciting for me. So the design here is we conducted a pretty large household survey, about 25,000 interviews in 27 different cities. These 27 cities are the capitals of each of Brazil's states. We used a complex sampling design, and so the results that I'm going to show you today are all based on estimates that use weights. And we asked about people the respondent knows and interacted with in the past year. That was the type of network that we asked about. And we're going to compare to the sibling method. So on our survey instrument, we collected the information that we need to produce death rate estimates using the sibling survival method. And then we also collected the information we need to produce death rate estimates for the network survival method. But then in these 27 cities, the quality of vital registration data for adult deaths is quite high. And so we'll also have vital registration data that we are going to be able to compare to. So this is going to give us some sense of how right these methods are in an absolute sense. I'm going to start by kind of comparing the 2 survey-based approaches to each other. And so the first thing that we might want to look at parallel to the Rwanda study is the number of reported deaths. And so I'm going to show you a plot here that has the the average number of reported deaths from the network method, from the sibling method pooling 7 years worth of reports, and then from the sibling method in the past year alone. And the y-axis here is going to be the average number of deaths reported per interview. And kind of consistent to what we found in Rwanda, we can see that there's many more reported deaths per interview in the network method. It works out to be about 13 times more deaths per interview than the sibling method. So that's a lot more information from the network reports. And as you might expect, that translates into the width of the confidence intervals for the estimates from the sibling method being quite a bit larger than the width of the confidence intervals from the network method. This plot just shows the distribution of the width of the ratio of the width of the confidence intervals for the sibling method to the width of the confidence intervals for the network method. So at 1, the uncertainty interval is the same width for both methods. To the right of this 1, the sibling estimate has wider uncertainty intervals, and to the left, the sibling estimate has narrow uncertainty intervals. So you can see that on average, the sibling method has quite a bit more uncertainty. Okay, I got a question, which is great. I think I'm gonna go through some results that might help to address this, but if not, please feel free to raise that again at the end. But thank you for the question. Okay, so now I'd like to compare how similar the actual death rates are to each other. So I'm gonna plot on the x-axis the log of the estimated age-specific death rate from the network method, and on the y-axis I'm gonna plot the log of the estimated age-specific death rate from the sibling method. And the colors are going to be denoting the age group, and then the sex is going to be given by the shape of the symbol that's plotted. And so what we see here is that there's the estimates are pretty similar to each other, but there are definitely some differences. In particular, some of these sibling estimates look like they're lower, and you may notice that there's some estimates that are plotted here against this along the axis. These are cases where there were no deaths reported in that age sex group from the sibling method, and so the estimate is 0. Okay, so what have we found so far from comparing the two methods to each other? Well, it looks like the estimates from the sibling method and the estimates from the network method are similar to each other. And as we sort of predicted, we found that we learned about more deaths per interview from the network method, and that translates into confidence intervals being wider for the sibling method. So far, so good. Now the kind of key question is, well, what about comparing these estimates to the vital registration data? So just to kind of pause and think about this for a second, there's a lot of decisions that go into producing death rate estimates from a survey, or really any estimates from a survey. And it's really important not to overfit. So we wanted to be disciplined about how we made this comparison. And so we didn't compare any of our estimates to the vital registration data until the very end of the analysis, quite recently, actually. And we pre-registered the comparison before we actually did it. So so we had to make some decisions about what quantities to compare and how to quantify the comparison. So how to get some sense of how accurate the estimates are. And we decided that the most important quantities to look at were the age-specific death rates, and then this probability of death at adult ages, which is a life table quantity that summarizes the age-specific death rates. And when thinking about how to make the comparison, we decided to look at the absolute relative error and then the mean squared error across all of the estimates. I'm not going to have time to go through all of the combinations of these results today, so I'm going to focus on the age-specific death rates and the relative error. And maybe I'll mention a few of these other things as we go through where they seem relevant. But I'm going to focus on the age-specific death rates and the relative error today. Okay, so so first we're going to look at a plot that compares on the x-axis the log of the vital registration age-specific death rate to the survey-based estimate for the vital registration for the age-specific death rate. And the left-hand panel here is going to be the estimates from the network method, and the right-hand panel is going to be the estimates from the sibling method. And again, these colors are going to denote age groups, and the symbol is going to denote male, female. So first, let's look at the network estimates, and we can see that there's a strong relationship here. If you look at the colors carefully, it looks like there's some challenges in the youngest age group here, which is something we'll see consistently throughout these results. And there's some scatter around this this y equals x line. Now, if we turn to the sibling estimates, we find there's also a strong relationship. There's quite a bit more variation, and we'll look at this in a few different ways. It's a little harder to see systematic deviations from the gold standard, from the vital registration data here. So this just shows the data. Now let's think a little bit about how we can try to quantitatively summarize how close or how far these estimates are from the vital registration data. And so to do that, I'm going to, as I mentioned earlier, I'm going to focus on this absolute relative error. And there's a couple of key things to think about here. So the first thing is that this is the absolute value of the difference between the estimate and the true and the vital registration value. So that means that pretty much higher is worse here. So it's not, there's no sign. It's bigger is farther from the vital registration value. And then the other thing is that because this is relative, we're dividing by the true or the vital registration death rate. And so that is useful because death rates change a great deal over these adult ages. They vary usually by more than an order of magnitude. So it's kind of tricky to compare across ages. This attempts to sort of treat the ages equally in the sense that it's kind of standardizing for how big the underlying death rate in each age group is. The mean squared error, which I'm not going to talk about as much today, does not do that the same way. So that's why we chose those two different metrics. Okay, so first we're going to look at kind of a complex plot that shows all of the errors in one place. And before we do that, I just wanted to look at this specific example so we kind of get a sense of what we're looking at. So this is a hex map that shows each of the cities roughly in corresponding to where the city is geographically. So this kind of looks like an outline of Brazil if you look at it. These hex maps are useful because they weight each city equally in terms of area, even if they aren't totally faithful geographically. So that's the rationale here. You could see that there's this color scale that shows the relative error. And it goes from sort of the lowest value is blue. So these are really good estimates here. And then the highest value is red. So that's like really not a great estimate. And this is for one age sex group from the sibling method. And so I'm going to show you an array that kind of shows these plots for all of the age sex groups in both methods. So it's going to be a little bit, there's going to be a lot of information here. We're going to kind of spend the next few minutes digging into this in a little more detail. So what we have here is a bunch of different versions of the plot that I just showed you. The left-hand two columns is estimates for females. The right-hand two columns is estimates for males. The rows are the age groups. And then within each of these genders, there's the network estimates on the left-hand side and the sibling estimates on the right-hand side. And so there's a few things that kind of leap out here. It's pretty clear that the youngest age group has the highest relative errors, and that's especially true for the network method. So part of that is because death rates at these young ages are just very low in an absolute sense. So the relative error is an especially kind of tough metric to use here. It's a little bit less clear if there's quite a strong an age pattern from the sibling estimates. It does look like the errors for females are a little bit higher than the errors for males. And sort of interestingly, I don't, looking at this myself, I don't see a strong geographical pattern here, which is a little bit surprising because these 27 cities vary a great deal in how wealthy they are. And so you might have thought that you'd see some kind of relationship between, and how wealthy they are is roughly correlated with geography. So you might have thought that you'd see some relationship between how well these different approaches performed and the kind of wealth or poverty on average of the city. I don't really see any evidence of that here. Okay, so one thing we can do to kind of get a better sense of these patterns by age and sex is to try and summarize the errors by taking the average across 27 cities for each age and sex group. So that's what we're going to look at next. The x-axis here is going to have the age groups, and the y-axis is going to have the average of these relative error, absolute relative errors across the 27 cities. The kind of purple line is going to be the network method, and the yellow line is going to be the sibling method, and the circle is females and the triangle is males. So if we look at this pattern of errors, we see pretty clearly that what we saw from the maps a second ago, which is that the youngest age group gives the network method a fair amount of trouble. But then the network method does quite a bit better for the older ages, and there's less of a dramatic pattern for the sibling estimates. But we do see here, if you look carefully, it looks like the sibling errors are consistently higher for females, which is kind of interesting. And I don't see a strong pattern here in difference between the errors. Difference between errors for females and for males from the network estimates. So So that's kind of interesting. It looks like so far one of the stories is that the network method is having special trouble in the youngest age group, but maybe is doing better in the older age groups. So finally, we can try to summarize these errors across all of the age groups and all of the cities to just get on average for each of these estimates which method does better. We see here, sorry, I should have said this y-axis here is the difference in the average absolute error between the network method and the sibling method. So when this difference is below 0, the network method is doing better. And then here we have the two different quantities of interest, the death rates, and then these probabilities of dying in adult ages. And by both of those metrics, it looks like the network method is doing better on average. It's more accurate on average. So that's good news for the network method, but it's not quite that simple because we've seen some evidence that the sample size is challenging for the sibling method. So we saw those cases where there are 0 reported deaths, for example. And if we think for a second about this framework that I've been using to try and kind of think through the difference between the sibling method and the network method, if the sample size got bigger, we'd expect this curve, this sampling error curve, to sort of shift or rotate downwards somewhat. And we don't think that it would really change the non-sampling error in the same way, because it's not, at least I can't think of any reason why changing the sample size would affect the non-sampling error. So you might ask, well, if we had a bigger sample, maybe the network method would have done a little better. And we can actually kind of try to look at that with our design, because Brazil's states are divided up into these different regions. And so what we can do is we can aggregate these cities into the regions that contain them, and then perform the analysis at the regional level and see what the comparison looks like. So I'm not going to have time to kind of go through those results in great detail, but I can kind of give you a preview here. This plot has the same structure as the one that we just saw for the city level estimates, but now we're going to focus on the region level estimates. And so what we find is that now we see some evidence that the sibling method may be doing a little better for the age-specific death rates, even though the probabilities of dying in adult ages still look a little bit better for the network method. Okay, so what did we learn from the data from Brazil? Well, in aggregate, the network method was more accurate at the city level, at least according to the relative error. And I didn't show this to you, but this turns out to also be true for the mean squared error. We didn't see any strong geographical patterns. Again, I was a little bit surprised by that. The sibling method seemed to produce higher errors for females, and there's no similarly clear pattern for the network estimates. So that's interesting. I think there's one. So I've recently worked in a paper on the sibling method, and I think there's one possibility is there's a technical explanation for this and how the standard sibling estimates are produced. But I can't be sure that's what's going on here yet. The network errors were very high for the youngest age group. And so I think that's pretty interesting and worth trying to understand better. One hypothesis here might be that people who die at young ages are very visible. So it's kind of more likely than average that others will hear about death to a very young person. And so if so, that's something we need to understand better empirically and kind of worry about a little bit with this method. Throughout, we saw some evidence in favor of this quantity-quality trade-off being a reasonable way to think about the trade-offs in choosing different types of networks to ask people to report about. So specifically, we saw that the uncertainty intervals were wider for the sibling estimates, which is what we predict. But then we also saw that there's this suggestion that as the sample size gets bigger, the sibling method becomes more accurate, which kind of implies the non-sampling error for the sibling method is a little bit lower. So that I'm kind of continue to be a believer that this is a productive way to think through how to come up with networks to ask people to report about in different settings. And then finally, we weren't sure the network method would work at all. It looks like it's a promising approach to estimating adult mortality, and it can be applied in some settings that we really don't have great solutions for right now. So for very recent time periods, relatively small samples, so on and so forth. Okay, so I left a lot of details out today. You may have questions about some of them. So I just to give you a sense of what you might find in the papers if you read them. I didn't talk at all about how we estimate network size. That's actually, I think, that's kind of interesting. I talked some about which network to ask about, but I didn't show you the results of the survey experiments in Rwanda that kind of illustrated how we can iteratively try different kinds of networks over time and get some sense of which network is more accurate. And if we do that repeatedly in studies, we might be able to start to fill in what these pictures look like and get some actual sense of whether we're near the best possible network. And then I didn't talk too much about reporting errors or differences in network structure, and that's something that the papers discuss a fair amount. It's quite it's interesting. I didn't have time to really talk about it today, but my guess is that many of you have questions about that. And then what's coming next? Well, so after having made the comparison to the vital registration data, we're going to continue to try to understand systematic deviations that each method has from the vital registration death rates. This might be useful in applying either of these methods in other settings. There's also a lot of interesting modeling you could potentially do with these data. And the Brazil survey had some collected responses needed to estimate some other quantities beyond death, including outmigration and the size of hidden populations that are relevant to HIV/AIDS, like people who inject drugs, sex workers, and so on. Then more broadly, there's a lot of other directions for future work in the realm of kind of these network reporting surveys. It'd be really useful to have more empirical results about different tie definitions to kind of get more purchase on this which network should we use question. I have a project on kind of using this approach to, in other words, asking survey respondents to report about others in the context of having an online sample and wanting to learn about more than just the people you talk to directly online. There's a methods paper on the sibling method, and I also have a project based on a survey in Hanoi where we're kind of trying to understand how to improve how some of these data are collected, and there's a lot of other possibilities too. Just wanted to thank again my collaborators on several related projects here, to some of the funders. And then if you are curious, you could check out some of the papers on my website, or please send me an email if you have any questions that we don't get to talk to today. So, thank you. Oop. Okay, should I just sort of go through the Q&A here? I can, let's see.
That seems like it makes the most sense to me.
What does visibility tell us about which deaths are most? So everybody can see this Q&A, right? I assume. Cool. Okay. Were there differences in visibility and gender of reported death? Yes, there were. So I didn't. So we are approximating the visibility by using the estimated size of respondents' networks, and I did not show you there are differences by age and sex in the estimated size of respondents' networks, which is what we're using to approximate the visibility. So the estimator that we use accounts for those differences. It's actually, if we didn't account for those differences, it probably wouldn't work nearly as well because they do vary a fair amount. I don't have the plot for you ready, unfortunately, but I think remember, we're using the size of respondents' personal networks to approximate this visibility. The actual visibility is sort of difficult to directly measure, but if we could directly measure it, it'd be really interesting to understand whether or not this visibility does differ by age and gender. The fact that there aren't huge discrepancies in the gender pattern of errors for the network method, to me, is some hint that gender is not, like, there's not a lot of differential visibility by gender. But the big errors for the youngest age group from the network method, that could be because people who die at young ages are sort of widely talked about, and it's much more like those are much more visible deaths in some sense. That's certainly possible. Okay, so I hope that, please feel free to follow up if that didn't answer the question. Are there respondents who are more informed about their network members than others? So that's a great question. So partially it's definitely true that people seem to vary a lot in how big their networks are, individuals. It would be really interesting to understand at the individual level whether some, kind of who produces more accurate reports and who produces less accurate reports. That would be really, I can't offhand think of how you might get at that empirically without somehow having a map of everybody's network, which maybe there would be some situations where that would be possible. But let me mention though, in the case of sibling reports about siblings, there has been some really cool work on this recently by Stefan Hellringer and colleagues. So because sibship is a relationship that's fixed over time, it's more plausible that you could find a setting where there are administrative records you believe about who is siblings with whom, and then you could conduct one of these surveys and compare the actual reports to the data that you have. And so they've actually done something like that at HDSS sites in Sub-Saharan Africa. And I think that they're continuing to work on that. And so that's super useful because that kind of design can also produce estimates that we can use to adjust the raw sibling estimates. If we know on average people tend to, forget about X% of their siblings, then that's something we can use to improve the estimates. For the network method, it's really difficult to, well, I'd love to hear suggestions, but I can't offhand think of an easy way to try to make that comparison at the individual level. But studies like this Brazil study are ways that we can try to get at that kind of thing in aggregate. Okay. What does this do to survey burden? That's a great question. It's a little hard to be completely general, but just very casually, in my experience, adding the questions needed to estimate death rates from the network method is something like 10 to 15 minutes of survey time. And you have to train the interviewers in asking these questions. So that's like a little bit more work during the training too. One kind of surprising thing that or maybe this isn't surprising in retrospect, but like the sibling method is actually really difficult to administer. I don't have the two kind of questions. I'd love to show you the two instruments because the sibling instrument is quite complex and really I think a pain for the interviewers to go through. The network method is also sort of different from the most conventional survey questions, but the network method just kind of qualitatively did not give us as much trouble as the sibling histories did here. So they're both moderately burdensome, but I actually I wouldn't say in comparing these two that the survey burden is a big differentiator. If I had to make a choice just based on the survey burden, I kind of think the network method is a little bit easier to implement, but I'm arguably a little biased. So thank you.
Sorry, since there isn't any other questions up there, Dennis,
Sure.
I'm kind of curious, can you talk a bit more on why the sibling method is biased for females?
Yeah, so I'm not, I haven't actually, I'm not sure. I can't be sure, but a former student and I recently wrote a paper that should come out soon on the sibling estimator. And it turns out it's quite tricky. The difference is that it's been unclear whether or not the respondent should be included in this, or how to account for the fact that the respondent. Sorry, let me back up 1 second. Let me say that what we're using, the results that I just showed you are the kind of most standard sibling estimators. So these are the ones that are used in all of the demographic and health survey reports and everything. And so that estimator is just, it turns out there's a small factor that I think that estimator is usually off by. It's hard to be definitive because it depends on kind of comparing two things we're making assumptions about, and we don't know either one. So, but I kind of suspect that it's off by a factor, kind of like the sibship size divided by the sibship size plus 1, or the reciprocal of that, I forget. But so not like a huge amount probably, but just a teeny bit. And so it's possible that is driving some of the discrepancies here. But I'm not confident of that yet. I mean, these results are pretty new. So yeah, this is an interesting question though, for sure. I mean, it's also, of course, possible it's not a technical thing and it's more of a sociological, maybe people are more aware when their female siblings die or something like that. It's certainly possible. That's the kind of thing that Stefan's work could help get some purchase on, for sure.
So some like kinship effect basically is.
Yeah, it could be. Yeah.
Hi, yeah, I was curious just on that note, I guess depending on ages of siblings, we have this issue with all DHS mortality reporting where if someone who is dead and doesn't make it into the sampling frame died for some reason, that their siblings are also more likely to have died, or their children are also more likely to have died, then we get bias in that way. And I wonder how much of that is part of the gender issue.
Yeah, good question. So, well, actually, just to be sure I understand. So a concern with the sibling method especially is that sieve ships die out entirely. And that means that nobody is left behind to report about anybody in the sieve ship. And if,
Right.
yeah, exactly. So, so I have a lot of thoughts on this. So one thought is, so that's an advantage of the network method, I think, is that it's pretty unlikely that a whole personal network of people will all die out together, except in some really horrible catastrophe. This concern in the sibling method, I think, is very valid, although I'm not sure it's quite as big a concern as the literature sometimes makes it out to be, for a couple of reasons. So first, at least in this study, I'm only looking at recent sibling reports, so up to 7 years before the interview. So some of the sibling literature takes these sibling histories and tries to produce death rate estimates, 20 years in the past, and I think that is really difficult. That's not. I wouldn't really do that. I mean, so Bruno Masquelier has done some pretty convincing microsimulation work that suggests that that can be misleading. It also turns out that unless the proportion of sieve ships that is systematically not included because of this zero survivor bias, as this is sometimes called, unless that proportion is really pretty big, it probably won't make a huge difference in the resulting death rate estimates, although maybe that could explain part of what we see here with the female death rates. I can't think offhand why that would affect females more than male reports, though.
I guess I was curious more about, and I don't know if this is an issue, but like, since, at many ages, males are more likely to die, is that driving any, like who is making, there's the zero survivorship issue. And then there's also, I was just thinking purely about sex and mortality. Is there anything going on there where like at certain ages, if men are much more likely to die, then they are not able to be sampled? It seems less likely than if we were talking about individual mortality due to the nature of the sibling method, but that was something.
Yeah, no, that's interesting. I haven't thought about that, and that's an interesting. I agree that I think it would be a little more of a concern if we were looking at individuals as opposed to reports about siblings, but it is possible that something. I'd have to think about that a little bit more. That's an interesting thought.
Cool, thanks.
Yeah, thank you.
If no one else is going to ask, I have one more question, and I just wanted you to talk a little bit more about how you estimate people's personal network size.
Yeah, sure, cool. Yeah, so that's something I left out, obviously. So, so for the network approach, actually, you could do this in different ways. So it depends a little bit on the network that you want to use. But for this network that we used in this study, which is very weak, a very weak tie network, it was people you had some kind of interaction with in the past year. That's an extremely weak tie. We use what's called the known population method. So that means that we ask the survey respondents a bunch of questions about how many people they know who are in different groups whose size we know. So for example, how many people do you know who are bus drivers? How many people do you know who became widowed in the past year? That, questions like that. We know the sizes of these groups from either the census or administrative records. And the intuition is that people who report more connections to these groups have bigger networks, and we can kind of anchor the size of the networks by knowing how big the size of those groups is. So we ask about questions to like 10 to 20 of those groups, and those questions go into the estimate for the network size. So, yeah. So one nice thing about that approach is you can perform that approach, by the way, I should say, was invented by Bernard and colleagues quite a while ago, but it's sort of being used more these days. Tyler, I don't know if Tyler's here, but Tyler McCormick has done some work using that approach. Some really interesting stuff about estimating homophily in network structure, I guess, or segregation in social networks based on those data.
Have you tried any other methods? You just described that's like the scale up method, right?
Yeah, right, exactly. Yeah. The network method is like a mashup of the sibling method and the scale up method, basically. And so, but like with the scale up method also, you could use different ways of estimating people's network sizes. So in Rwanda, we tried, I'm blanking on what it's called. So a different approach is to try to divide everybody's network into a bunch of mutually exclusive categories and to ask people how many they know in each category. Summation method. This is called a summation method. We found in Rwanda that was a little bit less accurate than this known population method. So in Brazil, we only use the known population method, but the summation method could be a reasonable approach in some contexts. It depends a little bit on how big you expect the networks to be, I think. So if the network is like medium sized, it seems plausible that people might be able to tell you how many people were in each of several mutually exclusive categories. For the known population method, the idea is it's not really possible for people to just enumerate everybody in their network. So what's some way we can try to get something related to how big their network is, kind of indirectly.
Interesting. Very cool. So it looks like we have 2 minutes. Anybody want to ask a last question while we have Dennis, or we can always send it off to the graduate students to ask the last questions in their separate meeting.
So the link is in the chat now, so please do attend. So we have the opportunity to talk more at the next session. So perhaps we should say goodbye, but thank you so much, Dr. Feehan, also to Dr. Almquist for arranging all this. It was really exciting.
Thank you. I really enjoyed it. Thank you very much.
Yeah, thanks, Dennis.
Okay.
This was great.
Thanks. I look forward to seeing the grad students in a second.
Okay, super. Thank you to everyone. We'll see you next week.